So I've kind of already introduced you guys to the idea that the slope of the tangent line at a particular point is found by um, using the difference quotient. So I've already introduced you guys to the fact that the tangent line gives me the slope um, of that line at a particular place on that line. And another way you may hear us other different vocabulary words that you may hear us use is instantaneous rate of change. So we may ask you to find the average rate of change or the instantaneous rate of change. Um, find the slope of the tangent line. So there's different vocabulary that math terms that we use. Well, they're all kind of um, talking about the same thing. But we've kind of introduced that concept to you already. All right, so for a function, y equals f of x, its derivative at x, so here's my x, and its derivative at that point is defined by f prime. You guys see me highlighting this? That's the way I read that, f prime. And f prime is defined by this right here. So we use the difference quotient, and we find the limit as h approaches 0 for the difference quotient at that particular point, provided the limit exists. So if f prime exists, so in other words, if we can find the difference quotient at that point, then we say that that function is what we call differentiable. Okay, in other words, we can find the derivative. That's what that means. So example 1, it's asking us to find, it wants us to find f prime. Then find f prime of -3 and f prime of 4. So the way, if we go back, I'm going to make sure you guys see this in our notes. The way that we find the derivative, and I'm going to write this down exactly the way they have it. The derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay. All right, so I know what my f of x is. It's right there. I just need to figure out what my f of x is, and I mean technically all that is replacing my x with that x plus h. So the derivative is equal to the limit as h approaches 0 for f of x plus h, which is going to be x plus h all squared, minus my f of x, which is just the x squared, all over h. Now, before I can actually find this derivative here, we have to actually simplify this. They're not going to tell you to now find the derivative in simplest form. You have to understand, or it's your job to, from now on, from this point forward, to always give the derivative in simplest form. So that's my job. My first and foremost job is to write this in its simplest form. If you guys remember, I'm gonna circle this in red. I told you guys how to easily. That's a B. Let's fix this. That's a mess. My kids call that chicken scratch. So A plus B all squared. The way that I square a binomial is by using the pattern a squared plus 2ab plus b squared. So using that information, I'm going to come back where I was at, and I'm going to square what I wrote, what I circled in red here. So that's going to be equal to the limit as h approaches 0 for x squared plus 2xh plus h squared minus x squared all over h. Now, if I'm moving too fast, keep in mind, guys, that you can pause this video at any moment and go back and think about what it was that I did. But I'm just going to highlight this. This x squared plus 2xh plus h squared comes from the x plus h all squared. Then I just brought my x squared over, and of course my h stayed on the bottom. Okay. And if you guys remember from the last lesson, we talked about how once you got to this point in your numerator, the only terms that are left there now should be terms that have h's, part of the term. Like somewhere in each term, you should see an h. So if I simplify this, I see that I have an x squared minus x squared. So they're going to cancel one another out. And I don't have any more like terms. So that's going to leave me the limit as h approaches 0 for 2xh plus h squared all over h. Now, once you get to this step, I need to divide. I need to divide everything in that numerator by h. And that's going to give me the limit as h approaches 0 for if I divide 2xh by h, those h's would cancel one another out. So that leaves me with 2x. And if I have h squared divided by h, that's just going to leave me with h. Now, at this point, guys, I have to go back and I have to remember how to find the limit. So how did we find the limit? Remember that I told you, and it's in your PowerPoints. I know we had confusion about it, or sometimes we have confusion about limits, about why we are able to substitute. But our shortcut says that we can just take this value and substitute that to find the limit as h approaches 0. So if I do that, that tells me, or what I'm left with, let's move this over, is 2x plus 0, which is 2x. In other words, what I have found is that my derivative, f prime of x, is equal to 2x. But I'm not finished. I'm going to zoom this back in just a little bit. What I have found is that f prime of x is equal to 2x. But now your problem, if I zoom out again one more time, it asks me to find f prime of -3, and then I need to find f prime of 4. So let's talk about this. So you really have two things that you're doing here in this problem. So the first step was that I had to find an expression that represents the difference quotient. How can I find the tangent line for that particular equation? So what I have is an expression here that allows me to find the tangent line at different places on the graph. But what this is asking me for is the actual slope of the tangent line at different places on the graph. In other words, this first one here, that is asking me to find the slope of the tangent line when x equals -3. That is literally what that's asking me to do. And it's very simple. I mean, I already know what f prime of x is. F prime of x is equal to 2x. That expression allows me to find the slope of the tangent line, at particular points on the graph, at particular spots on the graph. Well, I've just been asked to find the slope of the tangent line when x is -3. And literally, all I have to do is substitute that -3 into that expression. And what I found is that when my x is -3, the slope of the tangent line is -6. And the same thing's going to happen over here for f prime of 4. I want to find the slope of the tangent line. That's going to be equal to 2 times 4, which is going to be equal to 8.